guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. In our discussion today, I'm going to look at a concept under projectile motion, which is finding the final velocity before impact for objects which we refer to as projectiles. Now, in this particular case, we'll consider an illustration which we have generally been using for our discussion of the concept of a projectile motion. And this is going to be a motion of an object that is described using of course, this two-dimension plane, which is of course the x and y, and we had said that we can represent the velocity component of this specific object in terms of a vy naught and vx naught, which is going to be giving us the velocity component of this, as well as the velocity of this specific projectile, given in terms of a v naught. So at this specific point, we said that we're going to achieve the maximum height where the velocity is equivalent to the velocity along the x component, and of course at this maximum height we're going to have the velocity along the y component equivalent to 0. So at this point we're going to have the velocity final perhaps given in terms of that specific representation, and we are going to be finding the final velocity before impact, which is going to be given by this specific of course representation which I've given on the board. So we're going to consider this particular velocity from the equation of the value of the final velocity, or this velocity along the vertical component, given as of course sum over the initial velocity, the square of the initial velocity, and of course to the value of the gravitational force or attraction due to gravity, and then we are going to have this value for y. And in this case, I said that we're going to consider this specific value for y as the maximum height. And we had found a representation for this specific aspect of a maximum height from a previous discussion, whereby we said basically that this height can be given in terms of the value of y is equivalent to the product of this v naught, the square of that one, given as the sine square of beta all over 2g. And this is going to represent our maximum height achieved for this specific trajectory. So from this specific point, then therefore we can do an evaluation of this specific final velocity, whereby we're going to consider this specific value for a substitution for the value of y in this equation. So we're going to do that and see what kind of an equation we're going to get. And in this case, we had mentioned that basically at this maximum height, we're going to consider the velocity component of vy equivalent to 0. So therefore, we're going to take those two considerations. And in doing a substitution in this first case, which I had mentioned, we're going to have this value of vy squared equivalent to vy naught squared plus 2g, and then we're going to have a substitution for that one for v naught squared at the sine squared of beta all over 2g. So this is going to be giving us a version of the equation whereby we're going to have vy squared is equivalent to. So I've said that we're going to do a substitution for this specific value, whereby we're going to have this specific component at the maximum height given in terms of 0. So we can have this one given as that one. So if you try to look at this specific 2g, it's going to be the same as the denominator of that one. So we're going to have this value given in terms of a square of that one, the sine square of beta. So in this case, implying that we're going to have this value equivalent to v naught, of course, the sine of the sine square. So this is going to be the sine square of beta. So in us finding that one, of course, we're going to find the absolute value of that one. It's a positive value, which is a v naught, the sine over beta given as that one. And in our previous discussion, this specific representation, of course, is going to be giving us the y component. And therefore, we're going to see that the final velocity for this one, of course, this is going to be giving us the y component. The final velocity for this one is going to be basically equivalent to the initial velocity, which we are going to see, which is the velocity of our launch. And therefore, that's going to be the final velocity we reach this specific projectile is going to be perhaps impacting the ground with. So in this case, this basically is going to be equivalent to the initial velocity of our launch, which is going to be the final velocity with which this specific projectile is going to be hitting the ground given as that. So kindly check our description boxes for various links of other videos, engage us in the comment section, and also ring that notification bell for an update on various discussion in math and the sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.